Welcome back to my channel. Sweet Tips here, and I've got this piece of gold that we quartered with silver. Pulled the silver and base metals out with nitric, then we melted it up into this disc. And let's get a weight on this thing. We've got 59.3 grams of relatively high purity gold. But I think what we're going to do, I've got a special purpose for this thing. We're going to put this down into a beaker. And now what we'll do is we'll take it out in the fume hood and redissolve it and give it a second refining. Here we go. What we'll do is begin by adding some hydrochloric acid. I'm going to put about 400 milliliters of hydrochloric acid in here. Now I'll measure some nitric acid. I'm going to use about 60 milliliters because we've got this in solid metallic form. So it's going to take a little bit extra nitric to get this to go into solution. Add it right on in. And now we'll cover this up. Set it up on the heat and start dissolving the gold. That took about 2.5 hours. We've got all the gold to go into solution now. And so what we'll do is evaporate this down to a syrup to drive off any excess nitric acid that might still be in that solution. I had to add about another 40 milliliters of nitric during the dissolve sequence to get it all to go into solution. So now we'll evaporate this down to a syrup and drive off any excess nitric acid. I've had this on the heat, evaporating the solution down to a syrup now for about half an hour. You can see that there's fumes being produced inside the beaker. That's the nitric acid being driven off from the gold chloride solution. And we'll boil this all the way down until we get it to a syrupy consistency. And when all those fumes clear up in there, that means we've got all of the excess nitric driven off from our gold solution. This is the classic evaporation down to a syrup and then rehydration with hydrochloric acid to expel excess nitric acid from our gold solution. This is a 5-hour time lapse, and we do this over and over until no more fumes are being produced in the beaker. And we can tell when all the excess nitric has been driven off, when no more fumes will form when we evaporate it down to a syrup. Classic evaporation and rehydration with hydrochloric acid to remove excess nitric acid. We've got this evaporated down to a syrup now. I've got almost 2 troy ounces of gold in there in just about 50 milliliters of solution. So what I'm going to do, I'm going to rehydrate this now. We're still producing fumes in here, so we're going to add about 100 milliliters of hydrochloric acid, rehydrate this, and then keep evaporating until all those fumes disappear. See, it's very hot in there. Get the rest of this hydrochloric acid in. There we go. Now what we'll do is evaporate it back down again. Watch for fume production inside the beaker. If we get more fumes, that means that we're driving off more of the excess nitric acid that we had in there. You can see by the fume production just before we added the hydrochloric acid, quite a bit of fumes in there. That was the excess nitric acid being driven off as we evaporate the solution down to a syrup. We've evaporated the gold solution down again. It only took about 20 minutes to get that back down. I don't see any more fumes being produced in there. So what we'll do is we're going to pull this down off the heat now. Very hot. Just set it over here off the heat. I think it's safe to conclude that all the fumes, the nitric acid fumes, have been driven off. The reason we had a bunch of nitric fumes in here is because we used an excess amount of nitric acid to dissolve the metallic gold that we started with. It takes a lot more acid to dissolve metallic gold or powdered gold. And nitric acid, excess nitric acid in here will cause problems when we go to precipitate the gold. If there's a whole bunch of excess nitric in here, the gold will precipitate when we add the SMB, and it'll redissolve immediately, and it could do it violently if there's a whole bunch of nitric in there and cause it to boil over. So we want to get rid of the excess nitric before we do the precipitation. Excess hydrochloric acid in there is not a problem. The solution's fairly hot. I think what we'll do is cool it down with some ice. Gotta add this carefully or we'll tend to splash the gold everywhere. This will cool it off, dilute the solution, and precipitate out any silver chloride that may be present. While I'm thinking about it, let me add a little bit of sulfuric acid in here. And why we do this is to precipitate out any lead that may be present in our gold solution. Run this through the filter now. Look how clear that solution is. This is the piece of gold that we refined using inquartation only, and then we melted it into a puck. And you can look in here and see that the gold is very clean just from that process. Not a whole bunch of trash in here, and that's a testament to how effective inquarting with silver and imparting with dilute nitric acid is at cleaning the gold. Here you can see there's very little trash in our filter. So that gold disc that we dissolved in that Aqua Regia was fairly high purity gold, just like it was. Again, a testament to how effective quarting with silver and parting with nitric acid is at cleaning up our gold. Got the gold filtered. Let's get this funnel out of the way. As you can see, funnel's nice and clean. I've got a clean beaker with some ice in it. Here's our solution. Nice, clear and bright. It's got a little bit of condensate on the outside of the flask from it being cold. Comes the favorite part of the process. It's my favorite part anyway. I'm gonna precipitate out the pure gold with some SMB. Go ahead and add a spoon of it in. Do it, Morris. See a slight yellow tint to the liquid still, so add another spoon. And maybe one more. There we go, there's our white foam. That's an indication that we've got all the gold precipitated out of here now. I've allowed this gold to settle completely. And if you see, there's a little bit of color going on in there. So what we're going to do now is test the solution with some stannous chloride. Make sure all the gold is precipitated. And there you go. If we had any golds in solution here, that test would be a dark stain on the end of that piece of filter paper. Now what we'll do is pour off this waste solution into a temporary waste container. That's gold down in the bottom of my waste container. Some of it gets poured over when I do these rinses, which is quite all right, because we can just recover that gold later on. That gold looks real good down in there, just like it is after this first refining. Now what I'll do is rinse the gold over and over and get most of those chemicals off of there. Now
what we'll do is cover the gold with some hydrochloric acid. I'm going to set it up here on the heat and give this a boil in hydrochloric acid. This hydrochloric acid boil stayed nice and clear, colorless. So I think what we're going to do now is we're going to pour this off. Oops. Careful, Kev. Pour this off into our waste container. I'm going to give it a quick rinse with some water. Oh yeah, look at that, man. That looks, I'm going to say, delicious. Man, that's good looking, high purity gold. I must say, don't get no better looking than that. I've got my Sunday go to meeting melt dish out. Now we're going to get the gold down into this melt dish. Let me get this excess water out of here. Let's take our gold over to the melt table. Man, it really looks good here. And what we'll do is melt this up an ingot. And the reason we keep a flame on the mold, it's called a reducing flame. And we get a better looking bar if we preheat that graphite mold. And we do the pour with the flame going to keep the air off of the molten gold as it solidifies in the graphite mold. If we didn't have that flame, the air hitting the molten gold as it freezes would cause a frosty appearance on the surface of the ball. I'm using a cutting torch, oxyacetylene cutting torch head. I got the flame turned way down low. Notice that I'm concentrating the heat around the edges on the melt dish and not on the metal. Well. That bar is looking really good. High purity. Oh boy, look at that thing. Good Lord, look at that beautiful pure gold bar. Unbelievable. Never ceases to amaze me how beautiful this metal is when we refine it to high purity like this. Just beautiful. Here's our pure gold bar. The thing looks delicious. High purity gold. It's got a little bit of a scuff or a stain on there, just a little bit. This is just a single refining, so this bar looks just beautiful for one refining. Let's see what we got on weight. We started with what, 59.3, and now we've got 58.2, so we lost a little over a gram, probably out there in the waste container. And what we'll do with this thing now is that we've got it cleaned up like this. I think what we're going to do is build an electrolytic gold cell and use this pure gold bar as the anode for that video. We'll dissolve this in a gold chloride electrolyte using electricity and deposit the gold on a cathode that we make. We'll be doing that very soon here. So this will conclude this video. I'd like to thank everyone for watching.